Hey folks, it's Tom, your frugal prepper. So I'm out here with this 2005 Chevy Equinox. It's been on the channel before. It's the one that got wrecked and the control arm was all broke. I just finished that up. I got the new struts on it, and we put a steel wheel with the hubcap on it down there to get them by. But it's got no blower motor. So the blower motor's been tested with 12 volts and it turns and works. We know the blower motor's good. The blower motor resistor was replaced. Didn't make any difference. So now we got to figure out, we're going to start with powers and grounds and go from there. Pulled up some wiring diagrams and the all data, and now we're going to see what we can figure out. Alright, so where I'm going to start is just kind of know my enemy here. So I've got my blower motor right here, and that runs back through a C200, and that comes back to the fuse box. And then the ground path for that blower motor either comes back through the resistor pack, through one of these 3 switch positions, or direct in on full 12 volts here for the high speed. So, and then our ground path comes back here. It goes through a blower relay, which looks like it's controlled by the body control module for the control side of that relay. So its ground path is there. So we got on the switch a purple and a yellow. So this purple would be hot, coming through the blower motor, and this yellow would be our ground. So if we come down to the blower motor, we're going to have the red, white, which is our hot coming into the blower motor, and the purple down there. So we want to see with the blower set on high, if we have a ground here, and we have power here. And then of course we'll test the power and ground under load as well. So for this, I'm just going to be using the old Power Probe 4 that Erigo sent me a while back. And I use this quite a bit, but sometimes I still would rather use a test light, but this does make the job faster, especially this job. So I'm just going to go ahead and we'll get this hooked up to the battery. So I'm just going to take off my fuse box cover here, because that's got a positive. The battery's here under this computer down here. I don't want to mess with that, so I'm going to clip on right there. Just going to find us a good ground. I'm going to say this strut mount bolt will be good. Come on. We'll find us a positive. Go ahead and stretch out our tool. What I like to do so I don't accidentally pull these clips off is to kind of wrap this around something right here, like so. Plug her in. Woohoo, we got that. So, see 12 volts, ground. So, we'll go ahead and if I touch this right here, I got voltage. See if I got ground. Got ground. Okay, so now let's go do some testing. So this cover's already been removed, and this wire is off, and that's why I expect to see red with white stripe. That should be hot, and this one should be our ground path. If the switch is in the high position, probably have to have the key in, because the body control module energizes that relay. So we'll do that. Let's turn the lights off so we don't run the battery dead. Maybe. I guess this one doesn't let you turn them off. Piece of crap. Alright. So we'll go ahead and grab our power probe here with this camera. Alright. I'm just going to come in here. I'm not jamming this probe in here. I'm just, whoa, crap, biscuits. Alright, so I'm not going to jam this in here. I'm just going to lightly test. And we're not going to trip the button either direction here. We don't want to provide any power to it. We just want to see what we got. 2.2 volts on the positive. And I got a ground path there. So now if I turn the blower off. And yeah. So we got a good ground path, but I've only got 2.2 volts coming here. So we're gonna grab a test light real quick and try putting a load on that and just make sure that it is dead. Okay, so if this Equinox is like the others, I can pull this little fuse panel down from here off and I can grab a good ground right here. And so let me just find a hot fuse, test this on. And so we've got a good ground there. So we're gonna go into here, and it's not lighting the test light off of that positive. And I bet we have no voltage now. Yeah, now we got 0 volts under load. No load, we got 2.2. So we've got a bad connection. So let's go back to the fuse box and check it there. So here's our fuse box. It's covered. You're not really supposed to put back in usually, but okay, that's fine. So blower motor, HVAC is this 40 amp right here, HVAC blower. So we'll see if we got power. We got 12 volts. So the fuse is good. So I'm just gonna pry this fuse up out of here. Let's take a look underneath, make sure the connector's not all messed up or something. If I can get it, come on. Come on. So I just like to look down in here and make sure that's the no voltage side. 12 volts. So it'd be from this side of the fuse down. And I can see a little discoloration here, like maybe this has been hot a little bit. So what I'm gonna do is go ahead and pop this fuse out and take a look at the wiring underneath this fuse panel. And that's just because this is really easy to get to compared to getting to connector C200, which I printed out the location and it's in the driver's side kick panel, which isn't too terrible. But taking these bolts out, popping this up and looking is going to be faster. There we go. These little nitpicks are handy for just grabbing these side posts like this and taking them right out. You can just grab the round part without going on the actual hex. Ooh, okay. Alright, this is not a snap-on. I'm hoping this is going to work. It could just round the whole bolt off and snap everything and destroy the entire car. Oh, no, it worked fine. I don't know how well that socket really fits my hand, though. There we go. Alright, now we can get under here and take a look. See if we got any burnt wires or bad wires. So we've got, looks like 2 red with white stripes here that are probably positive. I also see reds with white stripes here. I just want to see if there's any dirt in these connections. Anything looks bad. The question is, which one is our red with white stripe? There. Those supposed to look pretty darn good and tight. I don't think we got a problem there. The question is which one of these might be our one that leads back to this fuse. So let's see if it's one of these connectors. The best way to do that is just probably a multimeter. Okay, so what I want to figure out is which of these red wires with the right stripe goes to this hot. And we know the voltage was coming out this corner side. So I'm just gonna see. Oh, I got lucky, it's this one right here. Alright. So now we know that that's this red wire right here. And so this connection looks okay up here. I don't see anything wrong upon visual inspection. So I think we're okay there. So what we're going to have to do is get this all put back together now. And then go down here and test this C200 in the kick panel. Okay, so now we just got to get this piece out here, however it comes out. Looks like it's this whole rail. There. Okay, now, see if you can see this. Let me get some light. So my diagram shows us this number 6 right here. It's these two. It's this connector or that one. Let's see here which one it is. It's this back black one right here. Is our connector that we're looking at. And so what I want to see is if I got a red one with a stripe in here. I do, I got one right here. So I need to see if I get voltage here. I want to get this connector apart and take a look-see at it. There. Okay, I see squeezing this. Okay. That disconnects this whole piece somehow. There it goes. Okay. So I'm just going to kind of take a look and see if there's a burnt one. And you see this burnt wire right here? Hoping you can see that. Let me see if I can zoom in on it. So this wire right here that looks brown, that's our red wire with the white stripe. And if we come right up here, you can see that that connection is completely burnt up. It's just gotten loose and it's overheated. So what I'm going to do in this case is not try to even replace this whole connector. We're just going to go ahead and cut that out of the harness and bypass it over to here, and then we'll retest. But let's see if you can see. Let me get some light on there. Right there, it's burnt up. And let's look down in here. You can also see in this connector it's been hot. So it's just gotten loose, it's drew too much current, and there she went. Alright, easy fix, Zeb, easy fix. Okay, so I'm just going to come out here and take this red wire that's burnt up looking. Let's get that right there. Alright. And then what I want to do is kind of cut that out of the harness. So I'm going to cut this electric tape. Okay, so I'm just going to take and cut some of this electric tape off here very carefully. And then we'll cut the same one here, and it's the second wire over. So this wire right here is hot, so we gotta be careful not to short stuff out while we're doing this. I'm going to get a piece of longer wire to put in here. Alright, so I'm just going to go ahead. I went up to the AutoZone and got some 12 gauge wire because I'm out. Guy tried really hard to sell me some fuel injector cleaner. Benefit of saving my fuel injectors and saving me from expensive repairs. So what I'm going to do is just put a longer piece in here so that if somebody wants to take this conductor apart before, this isn't sitting there holding it together. If somebody needs to get in here sometime in the future and troubleshoot. Let's go ahead and strip this off. Strip that off. There. Okay, now I just got to strip this little wire down here. If I can get to them, which I can. Get it into number 12. Alright, I guess it's time to get the soldering iron. Hang on. Okay, so what I'm going to do is just put a little of this MG Chemicals paste flux on here. If it'll come out. Come on. There it goes. Alright. A little bit of that down on there. I'll rub it in. I'm just going to go ahead and tin it. Wires that are hard to get to like this, I just tin them both and then stick them together with some hot solder. Okay. And now we'll take and tin up the other side that we're going to solder onto it. Some solder on that. Burns, burns, burns. Okay. We got a good connection. Okay. Now we'll slide this good heat shrink down over here. This heat shrink might be a little on the small side. It is. Let's go with this heat shrink. Right here. Okay, and we'll just heat it up, shrink it. Okay, now these are out here enough to where I can just kind of take them, put these two together, like so, kind of twist them. And I can put some flux on them. And before I do this, hang on, I need my heat shrink on here. Duh. Okay. Okay. Alright. In there, good and strong. I'm gonna let it cool a little before I put the heat shrink up over it. I'm gonna try to squeeze it down so the heat shrink will go. There. Alright, we're good. Now the next thing that I always do when I do a wiring repair like this, so that people know what's going on when they look in the future, I just put a label on. That way if somebody else pulls that out, they're going to know that's for the HVAC blower. Then we'll just kind of take this back up in here. Like so. We're going to unlock this back into place. Slide this back on. Over there like so. Good. Alright. Now let's go ahead and try it and see if the HVAC blower works. Thing is, I gotta reach up under here and finagle this HVAC blower connector back into place. There we go. Okay, so now we're gonna see if we got HVAC blower in this. Woo! We got air! Yeah! All the speeds work. Alright, I'm gonna leave that on high and let's take a current measurement and see how much current that's drawing. So I'm just gonna go ahead and pull my red wire out here and put this on current, 40 amp. I'm sure it's drawing less than 40. So we'll go ahead and zero it. And drawing about 15 amps. So that's gonna be fine. 9 amps, 8 amps, 2 amps off. There's a little 23 amp surge there when we turned it back on, but that's fine. Okay, I'm happy with that. Just make sure the blower motor isn't drawing some crazy amount of current right at the limit of the circuit, which might have caused the connector to get all hot and melt like that in the first place. Alright, so that guy is ready to go. It still has plenty of other problems, but that's what I'm fixing today. So there's that Yukon back there. I'm waiting on a new scan tool to come so I can get the fuel alcohol content pit out of it. And that's it. So good tea this morning. This one, I got one more I'd like to look at, but I haven't called, so we'll see what happens. But that's how you just kind of go through and troubleshoot wiring like that. Is remember, a lot of times things are fed power these days, and then they're grounded for the control. And so look at the components, check voltages, and check it with a test light under load. Put a little load on it, make sure it holds voltage. So just thought I'd bring you along for that one. You know, yeah, is my wiring repair perfect? No. It's really hard to get back under that dash in that corner with those short wires, so you do the best you can do, and I'm sure it'll hold and work fine for many more years to come. I'll talk to y'all later. This is Tom, your Frugal Prepper.